Hello guys, welcome back to the new video. So today we are going to solve today's lit code, which is making a large island. So first let me tell you, this is very easy question. Yeah, I saw that it's marked as hard, but you don't worry about the solution and the thinking because it contains a very easy logic. The implementation part is somewhat difficult, I can say that, but the logic is very simple means yeah. सो लेट्स स्टार्ट द क्वेश्चन मतलब मैं इजी बना दूंगा बहुत ही। चलिए शुरू करते हैं। सो व्हाट द क्वेश्चन सेज यू आर गिवन एन एनक्रोशन बाइनरी मैट्रिक्स ग्रिड यू आर अलाउड टू चेंज एट मोस्ट वन जीरो टू वन return the size of the largest island in grid after applying this operation. Which operation? Yeah, making 0 to 1. Okay, an island is a four directionally connected group of ones. Mm. So let's say the first example, which is 1 0 0 1. So if I'll make this 0 1, and I can say this is island which is of size 3. Okay, let's say if I make this 0 1, then I can say this is island of size 3. The thing is that I can only make 1 0 to 1. The same will go for here, so same will go for here. Now let me take a different example. Okay, so it will be easy for you to visualize, and it will cover all the different kind of test cases that possible to solve this problem. Yeah. So now let's say this is our input grid that is given. Now if we are changing this 0 to 1, and then this will be our area. This will be our island of size 6 plus 8 plus 1, which is of 15. Okay, if I'll make this 0 as 1, then yeah, okay, again the size is 15. But if I'll make this 0 as 1, now this will be our biggest grid, understood, of size 6 plus 1 2 3 4 6 plus 5 plus 8 plus 1, 11 plus 9 of size 20. Yeah, so the same thing we have to do here is what we have to do. We are changing 0 to 1, and then keep finding the size. Now many of you will think the brute force approach. What will be the brute force approach again? The brute force is that first I'll make 0 to 1, then from starting from here I'll do the DFS and I'll try to find the maximum island. Yeah, you can do this. So here what will be the time complexity for that? So for the brute force, for the each DFS, the time complexity is m cross n, as we have given the matrix, and we are doing for all the element. So again m cross n. So the total n power 4 is here, m is equal to n, and the constraints are n less than 500. So n power 4 will be approximate 10 power 8, so which will give a time limit exceed here. So that we have to somewhat do the optimization. Yeah, so what the optimization will be here, that's easily available. Like what I am doing here, I am making 0 to 1 and then make this as a graph. Okay, now the second case, and there's one more possibility, making this 0 to 1, then you make this as a graph. The third is making this 0 to 1, and then this as a graph. So here we are, what we are doing, we are dynamically making the graph. And when there is, okay, this you have to keep in your mind. When we are dynamically changing or dynamically changing of graph, at that time the best algorithm in use is called as what, disjoint set. Understood? Disjoint set is the best algorithm and the graph is dynamically changing. Okay, so means you have to think about the components. Okay, so it will be very easy. Like this is our one component, this is another component, and to merge these two component we are making here 0 to 1. Okay, understood? So first thing is that what we have now, then what we will do, we have the parent of this, which is contain size of 6, then parent of the right side, which is contain size of 8, and the one which we made 0 to 1. Like that we are getting answer here as a 15. Now the first thing we will do, that how do we know that how many elements are how the size of this parent. So that will be our first step. So what will be the first step? First step is for each element which is 1, each element which is 1, yeah, like this is 1, fine, do same thing what disjoint set union. So what will be uh, our answer here for the each element which is 1? So at that, if the element is 1, इट मीन्स कि हम लोग फिर उसका एक कंपोनेंट बना लेंगे यूजिंग द डिस्टेंस सेट. अगेन हियर द सेम थिंग, इफ द एलिमेंट हियर इज 1, देन वी आर गोइंग इट टू द फोर डायरेक्शन, लेफ्ट राइट, एंड वी आर मेकिंग अ सिंगल component here, then one single component here. So our first thing will be that. Okay, now after that what we will do, we will checking if now we have to convert 0 to 1. So we are traversing the matrix, we are checking if it is 0, yeah, it is 0. So we are making it as a 1, then we are go to the left side of it, we are checking the left side, find the parent, size of the parent, go to the right side, if it's 1, yeah, it's 1, then find the parent, ultimate parent, and size of that ultimate parent, and then we are doing the summation. Understood? Yeah. Now there is one problem here, means yeah, this approach is correct, but there is a one edge case kind of thing that we have to keep in mind. Let's say if we are making this 0 to 1. Okay, now here if we are going to left side, so there is no 0, yeah, that's fine. There is no 1, yeah, that's fine. But if we are going to bottom, then this component is there. If we are going to right side, then this whole component is there. Okay, and if we are going to up, then the same component is twice. Understood? The same component is counted as twice. So what we can do to avoid that situation, we can store parent, store parent इन सेट. सो हाउ इट विल बी यूजफुल, अगर हमने पेरेंट को सेट में स्टोर करवा लिया तो उससे होगा क्या कि if he, as you can see here, that for the right side and the upper side we are visiting the same component twice. बट अगर हमारे पास पेरेंट है ऑलरेडी स्टोर्ड तो हम सेट तो ऑलवेज डिस्टिंक्ट एलिमेंट ही स्टोर करेगा. हाँ, तो अगर हमारे पास रिपीटेड पेरेंट आ रहे हैं तो भी वो एक ही बार काउंट करेगा. ठीक है, तो इसके लिए हमें सेट चाहिए. अंडरस्टूड? और एक और केस पॉसिबल है कि लेट्स से, okay, if I- I'll make this as 0. Now it's also possible that okay, the case is there. uh okay, let me make this 2 also as 0. hmm okay, let me do more zeros. Okay, and now if I'll change this to 1, then the size will be 4 5 6 7. And if I, let's say this is also all are 1, then the size is 1 2 3 4 5 6 7 8. So 8 plus, if I'm making here one more 0 to 1 9. So the thing is here is that if I have some grid in which by replacing 0 and 1, they are not two or more component are joining, but instead there is a one single big component which is greater than the merging of two small component, then that is, so in that case we are just making that big component as one. ओके, आई थिंक नहीं समझ आया है, ठीक है चलो, इजी है। अगर मेरे पास ये केस है, ओके, लेट मी मेक इट दिस बिग ऑल्सो। अगर मेरे पास ये टेस्ट केस है, हम्म, तो अब अगर इसमें मैं यहाँ इस ज़ीरो को वन भी कर दूँ, या इस ज़ीरो को वन भी कर दूँ, मतलब दो सेपरेट केस में अगर मैं ज़ीरो को वन करूँ तो नंबर ऑफ टोटल आएंगे 7। ठीक है, अगर मैंने इस ज़ीरो को वन करके ये मर्ज कर दिया तो भी सेम 7 ही आएंगे। पर उससे इन दोनों छोटों के मर्ज से भी बड़ा है ये, जिसमें है 10। और अगर मैं यहाँ एक और ऐड कर दूँ बाय कन्वर्टिंग 0 to 1, then the total result we are getting is 11. So this is one more test case that we have to consider. Okay, so let me directly go to the code part, then it will be very easy for you to understand the same thing which I discussed here. So what I told you, what we will have to do, first we will have to make the components. So I have defined here the disjoint set, understood. Now if it's 1, yeah, as I told that if it's 1, then only we are converting it. So if it's 1, then we are checking its four direction as mentioned in the questions. These are the condition is valid. And if it's 1, if its neighbor is also 1, because we have to first make how many elements are there in the component. Then this is our node, this is adjacent node. Okay, and yeah, many of you thinking that what this operation is doing. So this is what we are doing is let's say we have this element 0. This is 0 1 2 3 4 5, 0 1 2 3 4. Now we want to make a single component from this 4. We want to make single component from this 4. So instead of storing a 0 0, then 0 1, then 1 0, then 1 1, what we are doing, we are directly converting this index into number. And how we are doing is, so if we have I and j, then I into row means number of row plus this j. You can, this is homework for you, you have to verify that whether this is correct or not. Okay, yeah, so this is the same thing, homework, verify for you, you have to verify this. Now to make the component, what we are doing, we are taking the one element here, we are taking the one element here, one element here, and we are finding, we are, what we are doing, we are doing the union of this both, means connecting. In one way we can check the connection of this both. Okay, and now this was the one part as I told you. Now the second thing, after we have components, yeah, like we have this, this, this. Okay, we have, let's say, three component. Now the second step is making converting 0 to 1. So we are first checking that if it's 0, yeah, it is 0, then we will go to all its four direction, and we are just find the size of the components which are connected to it in the four direction. So the same thing is due. So for finding, so before that, what we have to do, we have to store the parents into the set so that we will not get the duplicate parent. So for that, the set here is created, and we are inserting the neighbors into the set. And then after inserting neighbor into the state, we are just pop out. Yeah, as you can see here, we are traversing the set, finding the size of the parent, and we are adding into the total size array. And here one more thing is that plus, here we have to also add one more thing, which is the element itself that we made from 0 to 1. Let's say if I'm making this as 1, then the size of this plus size of this plus 1. Yeah, so that plus 1 is here, understood. And okay, so I write two times, yeah, it's wrong. But the thing is, this is the last case which I told that if this case is there, then what we will have to do, this is written here. So as we have the size of each parent of each node, so we are checking that till now the result we got, is it the ultimate maximum? So for that we are comparing it with the parent of each element and checking that the if this element's parent size is greater than till now the result what we got, then update it to the maximum and then return the answer. Yeah, so that was all about the question. Yeah, it's marked as difficult, hard, but no, not, it's not that much hard. The only thing is that you, if you know the DSU and some basic logic, then this question will be easy. If you want really good video on DSU, then please let me know in the comment. I will give you the best explanation. Thank you. Thank you guys.